the law of cosines. So like we did for the law of sines, I'm going to build the law of cosines. I'm going to derive the formula, and then we're going to see several examples of its use. Now again, this is a technique that we'll need to solve certain oblique triangles. So to build the law of cosines, like before, the first thing I'll do is I'll start by drawing an altitude to the side labeled C. And so here's my altitude. Here's my right angle. And I'm going to add a couple names here. Let me call this side, this measure H. And I'm going to call this measure right here, I'm going to call this measure X. I'm going to call this measure from the altitude to the angle beta, call this measure Y. Well, from right triangle trigonometry, let's build a cosine into this somehow. I know that the cosine of alpha is equal to x over b. And then I'll also notice that y is then if this piece measures x and the entire leg of the triangle measures c, then y is equal to c minus x. Alright, go back to the first equation. If cosine alpha is x over b, then x is equal to b times the cosine of alpha. And so then I can use that here for y. Y is equal to c minus b times the cosine of alpha. Okay, so now we've got some stuff set up. Now, we're going to come up with an expression involving a, b, and c and alpha. And to do that, we're going to start by using, amazingly, the Pythagorean Theorem. Not on the big triangle, but now on the small triangles that we've created. So now using the Pythagorean Theorem, I know that x squared plus h squared is b squared. And similarly, I know that y squared plus h squared is a squared. So that means that h squared, from the first equation, h squared is then b squared minus x squared. And similarly, h squared is a squared minus y squared. So if h squared is one thing and h squared is another thing, so then we can set them equal to each other. B squared minus x squared is then equal to a squared minus y squared. Okay, so let's use that and now make some substitutions. X, let's replace x with b cosine alpha. Y, let's replace that with c minus b cosine alpha. So then b squared minus, and instead of x, b cosine alpha squared must then equal a squared minus, and instead of y squared, c minus b cosine alpha squared. Alright, so let's see what we have now. Let's simplify this. I have b squared minus b squared cosine squared alpha equals a squared. Now what I'm going to do here is I'm going to expand the binomial square and subtract. So I'd have c squared minus c squared minus 2bc cosine alpha, but times a negative, plus 2bc cosine alpha. And then I would have a plus b squared cosine square alpha times a negative. So minus b squared cosine square alpha. Alright, so notice that we have a couple of terms here that add to 0, right? Minus b squared cosine square alpha and a minus b squared cosine square alpha. Alright, and so then those add to 0, and then there's different ways we can write this, but the common way to write this would be to isolate the a square. And so then if I isolate the a square, I'd have a square, and then I'd have equals b square plus c square minus 2bc cosine alpha. And this is known as the law of cosines. A square is equal to b squared plus c squared minus 2bc cosine alpha. So notice how this relates the sides. A square, we add together the other two sides, the squares of the other two sides. We subtract the product of 2 times the other two sides and the cosine of their included angle. So see BC and the included angle, BC and the included angle in that term. Now, if I had drawn the triangle differently, or if I had drawn the altitude differently, I could get a different form of this law of cosines. So another form reads that b squared is equal to, well, let's see, if we wanted b squared, that would then be a squared plus c squared minus 2ac cosine beta. And if I wanted c squared, that would be a squared plus b squared minus 2ab cosine gamma. And so these are collectively known as the law of cosines. So this is something we want to know. This is the law of cosines. All right, so let's see how we can use this. Solve the triangle if A is 32.6 meters, B is 25.0 meters, and gamma is 105 degrees. So let's see. Let's write these in. A is 32.6 meters, B is 25.0 meters, and gamma is 105 degrees. So notice that we have a side, the included angle, and another side. This is the side angle side situation. And to solve this, we can use the law of cosines. The first thing we would do, so if we think about what we have two sides and the included angle, and so this fits perfectly into the law of cosines. And so I'll use the law of cosines where I'm going to solve for the c first. So c squared is then a squared plus b squared minus 2ab cosine gamma. C squared is 32.6 squared plus 25.0 squared minus 2 by 32.6 by 25.0 by the cosine of 105 degrees. And we calculate this. All right, so let's see, 32.6 squared plus 25.0 squared minus 2 times 32.6 times 25.0 times cosine of 105 degrees. Let me check my mode. I'm in degree mode. All right, so let's enter that. Now that's c squared. We don't want c squared, right? We want c. So now, let me go ahead and write this. C squared is approximately 2109 point blah, blah, blah. And then we want the square root of this. So let's take the square root, and we hit second and the negative button to bring up our last answer and hit enter. 45, let's take this just to one decimal place, 45.9. So C is approximately 45.9 meters. So now let's look at what we have. See, now I have an angle and an opposite side. Now I can use the law of sines to solve the remaining pieces. All right? And in this situation, we already have an obtuse angle, so we know there can't be any more obtuse angles. We don't have to worry about that issue that we saw in the previous section with worrying about could there be two possible triangles. That doesn't happen except for that side-side angle situation. So now I'm going to use Law of Sines. But generally what we do is we solve for the smaller remaining angle because we know the smallest angle in a triangle must be acute. So let's use the Law of Sines to find the smaller remaining angle. So let's look at the sides. We have 45.9, 32.6, and 25.0. So beta is going to be the smaller remaining angle in this case because it's opposite the 25.0. Remember, in a triangle, smallest side, smallest angle. All right, smallest side is opposite the smallest angle. So let's solve for beta. So now the sine of beta is to 25.0 as the sine of 105 degrees is to 45.9. So then sine beta is 25.0 sine 105 degrees over 45.9. And so then beta would be the sine inverse of that quantity. Let's calculate that. Oops. Sorry about that. All right, so second, sine 25.0 sine 105 degrees divided by 45.9. Close off the inverse. 31.7 degrees approximately. Now for the last remaining angle, we could use the law of sines again, but once we have two angles, finding the third angle is relatively easy. So then alpha would be 180 degrees minus 105 degrees minus 31.7 degrees. Which is 43.3 degrees. Alright, so to use the law of cosines in the side angle side situation, we first use the law of cosines to solve for the third side of the triangle. Use the law of sines to find the smaller remaining angle, and use the fact that there's 180 degrees in a triangle to find the third angle. So now would be a good idea. Now would be a good time to try this one on your own. Solve this triangle. All right, so here we're told that A is 1.45 miles. Beta is 52.3 degrees, and C is 2.29 miles. And we're asked to solve the triangle. So notice again, I have a side, included angle, and a side. Side angle, side. So I'll use the law of cosines to solve for the remaining side, which in this case is B. So using the law of cosines, B square would then be A square, 1.45 square, plus C square, 2.29 square, minus 2 by 1.45 by 2.29 by the cosine of 52.3 degrees. All right, so let's see. We have 1.45 square plus 2.29 square minus 2 by 1.45 by 2.29 by cosine 52.3. Now again, that's c square. Sorry, not c, b square. So b square is 3.285, etc. But again, we don't want b squared, we want b. So we find the square root of that answer, 1.81. So b is 1.81 miles. So we've used the law of cosines to solve for b. And we now know that b is 1.81 miles. Now I know an angle and an opposite side. I can apply the law of sines to solve for the smaller remaining angle. I will solve for alpha now. Let's find alpha. So now the sine of alpha is to 1.45 as the sine of 52.3 degrees is to 1.81 miles. So then we multiply by 1.45 and use the inverse function. Alpha would be the sine inverse of 1.45 sine 52.3 degrees over 1.81. We calculate this. Sine inverse 0.45 sine 52.3, close off the sine, divide that by 1.81, close off the inverse function, hit enter, 39.3 degrees. Alpha is 39.3 degrees. And then once we know alpha, the remaining angle gamma is easy to find. Gamma would be 180 degrees minus 52.3 degrees minus 39.3 degrees. Alpha is 88.4 degrees. I'm sorry, gamma is 88.4 degrees. So there's a couple examples of how you can solve the oblique triangles if it's the side angle side situation by first applying the law of cosines. So now let's look at another situation. Alright, so let's consider a new situation. Solve the triangle if A is 15.9 meters, B is 27.7 meters, and C is 39.6 meters. Alright, so let's see what we have here. A is 15.9 meters. B is 27.7 meters. And C is 39.6 meters. So if we look at this, we have all three sides of the triangle, right? So this is the side, side, side situation. So when we have the side, side, side situation, we don't have any angles. We obviously can't use the law of sines to begin with. So we're going to have to use the law of cosines. The good strategy to use is to first solve for the largest angle. So we'll use the law of cosines, to solve for the largest angle, which in this case is going to be gamma, since it is opposite the longest side. Alright, so we will have to use the form of the law of cosines that involves the gamma. So we'll use the fact that c squared is a squared plus b squared minus 2ab cosine gamma. So then 39.6 squared is a squared, 15.9 squared, plus b squared, 27.7 squared, minus 2 by 15.9 by 27.7 by the cosine of gamma. All right, so I've got this equation, and notice that there's only one unknown here, and that's the cosine of gamma. So I have to solve for the cosine of gamma first, and then I'll use the inverse function. All right, so let's see. To solve for cosine gamma, I'm going to subtract these terms. So I have 39.6 square minus 15.9 square minus 27.7 square. Then I would have to divide by this factor to isolate the cosine gamma. So divide that by negative 2 times 15.9 times 27.7. And that would be cosine gamma. So then gamma is then the cosine inverse of that whole thing. Now, I usually recommend that we do this in a couple of steps, just because of issues with inputting it into the calculator. So I'll first do 39.6. I'll subtract the 15.9. Oh, and I forgot to square it. Let's clear that out. 39.6. Let's square that. Subtract 15.9. Square that. Subtract 27.7 and square that. Let's hit enter on that. Now I've got to divide that whole thing by the negative 2 times 15.9 times 27.7. So let me hit the division key, parentheses, because I've got multiple factors in the denominator. Negative 2 times 15.9 times 27.7. Close off the denominator. Hit enter. So I've got this negative this value. So let me go ahead and put that in, negative 0.622187. Now, second cosine brings up the inverse function, and the negative key brings up the answer. 128.5 degrees. So gamma is 128.5 degrees. And so now that we know this value, now what we do is now we're basically in the same situation as we had earlier with the side angle side. So now what I'll do is I'll solve for the smaller remaining angle. So solving for the smaller remaining angle, that would be alpha. Alpha is the smaller remaining angle in this situation. So sine alpha is to 15.9. Now I could use the law of cosines again, but there's a lot of work involved with the law of cosines. So we use the law of sines at this step. Sine alpha is to 15.9 as sine of gamma, 128.5 degrees, is to C, 39.6. So then we go through our algebra and inverse trig function. Alpha would then be the sine inverse of 15.9 sine 128.5 degrees over 39.6. And we'll calculate that. Second, sine brings up the sine inverse. 15.9 sine 128.5 degrees. Close off the sine. Divide that by the 39.6. Close off the inverse sine function. Hit enter. 18.3 degrees. So there's alpha. And then once you have two angles, the third angle is easy. Beta would be 180 degrees minus 128.5 degrees minus 18.3 degrees. $33.2 degrees. All right, so we've solved that triangle for the side, side, side situation. All right, let's take a look at another one. And this would be a great time to pause. Try this one out on your own. Alright, so here we're told that A is 12.8 centimeters, B is 9.72 centimeters, and C is 9.95 centimeters. So then, again, this is a side, side, side situation. A is the longest side, so I'll want to solve for alpha first. Right, the largest angle is alpha, so I'll solve for alpha using the law of cosines. 12.8 square would be 9.72 square plus 9.95 square minus 2 by 9.72 by 9.95 by the cosine of alpha. So then the cosine of alpha would be equal to 12.8 square minus 9.72 square minus 9.95 square over negative 2 by 9.72 by 9.95. Let's do some calculations now. Alright, so I'll go ahead and do this all in one. 12.8 square minus 9.72 square minus 9.95 square. There's the numerator. Close that off and divide that by the denominator. Put parentheses around the denominator. Negative 2 by 9.72 by 9.95. Close off the denominator. Hit enter. Alright, and so then cosine alpha is approximately 0.15324. And so then alpha would be the inverse cosine function of that. And so alpha is, let's find out, second cosine of that answer is 81.2 degrees. Alright, so now that we have alpha, then we'll solve for the smaller remaining angle, and so the smallest remaining angle is beta, right? Because B is less than C, so let's solve for beta. So then the sine of beta is to B, 9.72, as the sine of alpha, 81.2 degrees, is to A, 12.8. We go through our algebra and trigonometry here, so then beta would be the sine inverse of 9.72 sine 81.2 degrees over 12.8. So sine inverse 9.72 sine 81.2 divide 12.8. Close that off. 48.6 degrees. And so then gamma is 180 degrees minus 81.2 degrees minus 48.6 degrees. $50.2 degrees. Alright, so that concludes the techniques. We've now see how we can solve oblique triangles for all the different possible cases where we can solve them. And so now let's see some applications. So here we've got this word problem. We're told that two lookout posts, A and B, which are located 12.4 miles apart, are established along a coast to watch for illegal foreign fishing boats coming within the 3-mile limit. If post A reports a ship S at angle BAS is 37.5 degrees, and post B reports the same ship at angle 19.7 degrees, how far is the ship from the shore? Well, let's diagram this. Let's see. We've got the shoreline. So there's A and there's B, and we know that they're 12.4 miles apart. And there's some ship S out here. So let's say here's ship S. And post A reports the ship S at angle BAS. So remember, in this notation from geometry, BAS means A is the vertex, and the angle is B. So B from BAS, so there would be the 37.5 degree measure. And similarly, ABS, this would be the 19.7 degree measure. Obviously, this is not drawn to scale. And we want to know how far is the ship from the shore. All right, so we're really trying to solve, what is this measure right here? How far is the ship from the shore? So one way we could solve this, and it's not the only way, would be to use the law of sines to solve for either of the remaining sides of the triangle, and then use right triangle trigonometry to find the actual distance. So to do this, my first step would be I need to know the remaining angle. What's the remaining angle? ASB. Let's just call it angle S. So angle S, using the law of, just using the fact that it's 180 degrees in a triangle, would be 180 degrees minus 37.5 degrees minus 19.7 degrees. All right, we bring up our calculator. So that's 180 minus 37.5 minus 19.7, 122.8 degrees. Now, I can use the law of sines to solve for either of the remaining sides of the large triangle. It doesn't really matter which one we solve for, just arbitrarily. Let me solve for AS. Let me call this measure X. So then, using the law of sines, I can say that the sine of 19.7 degrees is to X as the sine of 122.8 degrees is to 12.4. So then, using a little bit of algebra, let's see, we use cross products and we divide. So then X would equal 12.4 times the sine of 19.7 degrees over the sine of 122.8 degrees. And let's calculate that. So that distance X is approximately 4.97 miles. But again, that's not what we were asked for. We were asked how far is the ship from the shore. Let's call that D, that distance, ship to the shore. See, now I can just use plain old right triangle trigonometry. Since I made that a right triangle, I made this right angle. The distance from the shore we assume is at a right angle to the shore. And so now I can use some right triangle trigonometry. So I've got the 37.5 degree angle, and D is opposite, and X is the hypotenuse. So I can now say that the sine of 37.5 degrees is D over 4.97. So then D is 4.97 sine 37.5 degrees, just using right triangle trig. And so 3.02. D is actually 3.03 miles. Alright, so in this context, that would mean that the fishing boat is outside the 3-mile limit, so we shouldn't call the Coast Guard to report this ship. Here's another situation. We're told that Los Angeles and San Francisco are approximately 600 kilometers apart. A pilot flying from Los Angeles to San Francisco notices when she is 200 kilometers from Los Angeles that the plane is, and this should read 20 degrees. I forgot that. So the plane is 20 degrees off course. How far is the plane from San Francisco at this time? Alright, so now would be a good time to pause. Try this one out on your own. Alright, so we don't really need to know much other context. I mean, it turns out that Los Angeles and San Francisco, if you don't know the geography, Los Angeles is roughly south of San Francisco. So if you wanted to draw this, here's San Francisco, and here's Los Angeles, and we know that the distance between them is 600 kilometers. Now, the pilot is flying from LA to San Francisco, notices when she is 200 kilometers from Los Angeles that the plane is 20 degrees off course. So if we assume that the course would be the direct route from LA to San Francisco, then when we're 20 degrees off course, and the distance now is 200 kilometers. So that's where the pilot is right now. 200 kilometers is how far she's flown, 20 degrees off course. How far is the plane from San Francisco? We want to know, what is this distance? Let's just call it x. And so if we look at what we have here, we have the side, we have two sides of the triangle, we need the third side of the triangle, and we have the included angle. We have the side angle side situation. So we can apply the law of cosines. So then x squared would be 600 squared plus 200 squared minus 2 by 600 by 200 by the cosine of 20 degrees. And so then x would be the square root of that result. So we bring up our calculator, do the calculations, and I'll just do it all in one step. The square root of 600 squared plus 200 squared minus 2 by 600 by 200 by the cosine of 20 degrees. 418. X is approximately 418 miles. So, in that situation, if we were 20 degrees off course and we've already flown 200 kilometers, this remaining distance is 418 miles not miles. We were in kilometers. Kilometers. Alright, so that concludes this section on oblique triangles and the law of sines and the law of cosines.